All right, now we're about to do partial fraction decomposition. So we're going to start this section with remembering how to write rational expressions into partial fractions. And hopefully you saw some of this in pre-calculus. So I'm just going to kind of remind you about that. Also, what is partial fractions? It's like in the past, in intermediate algebra and other courses, you've been interested in taking two fractions and writing them into one. And how you had to do that, you had to multiply the denominators together and get the single numerator. So for instance, we would say, oh, x plus 4 times x minus 3 will be our new denominator. So we had to multiply 1 times x minus 3, and we had to multiply 2 times x plus 4, and then we would get our new numerator. Now what we're interested in, and so let me just finish this. This is going to be x plus 2x is a 3x. A minus 3 plus 8 is 5. Okay, so we were interested in taking two fractions and adding them together and getting a single fraction. But now we're interested in taking a single rational expression or fraction and rewriting it into what's called partial fractions. The reason we're interested in doing it backwards is because we are interested in integrating. And as you've seen, integration can be tough sometimes. We don't always know how to handle it. We got to think about it and say, what methods can we use? What can we do? So when we're presented with something that's kind of complicated, partial fractions is a help. So in general, if the numerator of the fraction or the rational expression is greater than or equal to the denominator, the first step would be to divide, because it's not ready to be written into partial fractions. And then after you've done that, you deal with the remainder. If it comes to you with the numerator less than the degree less than the denominator, then the next step would be to factor the denominator. And then after you factored it, we set up our template. So right here, these examples I'm just using to remind you how to set up the template. So if you have a numerator and denominator ready to go and it's been factored, and the factors in the denominator are linear in form. This is to the first power, linear, linear, linear. You would set this up as something over x plus 7 plus another fraction over x plus 4 plus another fraction over x minus 3. And then you would say, okay, I need to put something in the numerator. It's got to be a degree less than this, and so that's just going to be a constant. So you just put A, B, C. You don't have to use A, B, and C, but 3 different variables to represent 3 different constants. That's the template set up for that one. We have not done the full partial fraction decomposition. We're just practicing template right now. Right here, if you have linear expressions and a repeated one, how do you deal with the repeated one? Well, first let's take care of the one that's not repeated, x minus 3. Okay, he's taken care of. Now let's deal with the repeated one. You have to repeat it as many times as there is a power. This will repeat 3 times. It's going to be something over x plus 1 to the first power, x plus 1 to the second power, x plus 1 to the third power. You repeat it as many times as it is the power. Linear expression deserves a constant in the top. Linear expression deserves a constant in the top. Now if you look at x plus 1 and you squared that, that would not be linear, that would be quadratic. But you base what you put in the numerator off of what you're repeating. What we're repeating is linear. So linear deserves a constant. We're repeating linear, it deserves a constant. Okay, what if we've got something like this? X squared plus 1 can't be factored any further with real numbers, and that's what I call factoring. So this is quadratic. That means what goes in the numerator of this fraction will have to be linear in nature. So we'll see what that looks like. First, let's deal with the x. This is linear. Okay, this deserves a constant, a. This is quadratic, so 1 less than quadratic would be linear, so this is going to be bx plus c. That's the format for when you have to put something linear in the numerator. Down here, what have we got? We've got 6x is 1, and then we've got x squared plus 5. Cannot be factored further, and it's repeated, so we got to repeat it the number of times. So this is x squared plus 5. X squared plus 5 squared. Okay. So what, this linear deserves a constant, a. This quadratic deserves something linear in nature, bx plus c. Base it off what you're repeating, quadratic, so another linear, dx plus e. So that's just a quick reminder of the setup. If you need more instruction on that, I have other videos. If you go to the YouTube site, there's like all kinds of videos on partial fraction decomposition from my pre-calc class. So let's go on, and now let's practice writing some expressions into their true partial fraction decomposition, where we go ahead and solve for the variables a, b, c, d, e, whatever we have to do. So the first one on our sheet is x cubed plus x over x minus 1. All right. When I look at this, the numerator is to the third power and the denominator is to the first power. This is not ready to be written into partial fraction decomposition because of the way the degrees are. I have to divide first. You can long divide or you can use synthetic in this case. I'm going to use synthetic because it's fun. 1 will go into 1 placeholder, x squared placeholder, x cubed, x squared. This is my layout. So I bring down the 1 is 1 is 1, add, 1 is 1 is 1, add, 1 is 2 is 2, add. All right, so is that right? Oh wait, did I go too many times? X cubed, x cubed. I don't think I had to go that far. But anyway, let's just do this. So when we rewrite this, this is going to be my remainder. This is x to the 0. This is x to the 1. This is x to the 2. So what I'm left with is 1x squared plus x plus 2 plus 2 over x minus 1. And I don't have to do anything else with this because this I can integrate. This is not a problem. So I didn't have to rewrite this into partial fractions. All I had to do was divide that one. So that one's done. Now let's do something that will involve partial fractions. Number 2. 2x squared minus x plus 4 all over x cubed plus 4x. Okay, this is less than this, so we need to rewrite this one. Now, look at your denominator. The next step is to factor it. So let's factor this. This would be, I can pull out an x, and that will leave me, if I pull out an x, I can write that as x times x squared plus 4. Okay. This will not factor using real numbers, so that's as factored as it can be. So I'm ready to start my template. This is going to turn into something over x plus something over x squared plus 4. Okay, what goes in the numerator is a degree less than 1, which is 0, so some constant, a. This is quadratic, so 1 degree less would be something linear in nature, bx plus c. So now we begin the process of figuring out what is a, what is b, what is c. So how you begin this process is you kill the denominator, and you do that when you have an equation by multiplying both sides by the lowest common denominator. You never have to figure that out when you're doing partial fractions because it's always going to be this one. It's always going to be that one. So you multiply both sides by x times x squared plus 4. X times x squared plus 4. And this will distribute to both terms. Right here, when I multiply this times this, those go away. I'm left with 2x squared minus x plus 4 is equal to, when I multiply, I'm going to copy this down again, x times x squared plus 4. When I multiply a over x times x squared plus 4, the x's divide out, and I'm left with a times x squared plus 4 plus, right here, x squared plus 4 into x squared plus 4 leaves me with bx plus c times an x. All right, so then I'm just solving this. Let's see. I'm going to distribute, no. This is something I'm going to use, this is something I learned called the cover-up method, which is kind of cool. And I'm going to use a different method in another one. I'm going to use setting up a system of equations, which you could also do here. But this is a nice one set up for called the cover-up method, which might help us solve some of this. Will it work? Let me see if I can get this to work. Well, I could try to do this. I'm going to do systems of equations for this one. So let's do this one. It goes like this. What you would do here is distribute the ax squared plus 4a plus bx squared plus cx is equal to 2x squared minus x plus 4. Okay, gather up your x squared terms, leaving you with, and I'm factoring it out, leaving me with a plus b. Then I have a plus cx plus 4a. Over here I have 2x squared minus x plus 4. Now to finish solving this, I'm just simply going to set the coefficients equal to each other. The constant term is 4. I'm going to set that equal to the constant term. 4a is 4. Solve for a. A is 1. Okay. The coefficient in front of the x is -1, and the coefficient in front of the x is c. C is -1. I didn't even have to solve anything there. A plus b, that coefficient is equal to 2. It's equal to 2. But I know that a is 1. So I subtract 1 and I get b is 1. Now I know what a, b, and c are. So to write this, number 2, 2x squared minus x plus 4 all over x times x squared plus 4 is equal to this in partial fractions. A over x, or 1 over x, plus 1, b is 1, and c is -1. X minus 1 over x squared plus 4. Now I'm just going to double check to make sure I didn't make a mistake. 1 over x, x minus 1, x squared minus 4. Like it. Okay, so that's number 2. Let's do a couple more. 3 and 4. What do those look like? All right, 3 goes like this. Oh, that was 3. Okay, sorry. Now I'll do 2 and 4. Sorry. Number 2 goes like this. X squared plus 2x minus 1 all over 2x cubed plus 3x squared minus 2x. Okay. Power in the numerator is less than the denominator. All right. Next step would be try to factor the denominator. I can pull out an x. Good. That leaves me with 2x squared plus 3x minus 2. And then I'm going to try to factor this guy. You can use whatever factoring method you learn. What do I like? Product sum method is a good one. Let's see, that's going to be x. This is going to be plus 2 minus 1. 2x squared plus 3x minus 2. This works. So I'm going to rewrite this into factored form. That was the next step, if you can do that. So that's helpful that we were able to rewrite it. All right, now I notice linear. So this is going to be something over x, something over 2x minus 1, something over x plus 2. These deserve constants. Okay, now, kill your denominator. Great. I'm going to multiply both sides by x times 2x minus 1 times x plus 2. Over 1. And over here, x, 2x minus 1, x plus 2. Okay, it will distribute to each one of those terms. So what I have left on the left, these cancel. I'm just left with x squared plus 2x minus 1. Over here, a over x times this. The x's will cancel. I'm left with a times 2x minus 1 times x plus 2. b over 2x minus 1 times this. The 2x minus 1 will cancel. I'm left with b times x plus 2. C times over x plus 2 times this. I'm left with cx times 2x minus 1. Okay, now I'm going to show you the cover-up method, which is a kind of cool method you can use sometimes. And it just makes it a little easier when you're trying to solve for A, B, and C. Not everyone is set up to work easily with this, but this one is. So what I can do here is say, well, what if I let x be 0? Okay, let's let x be 0. Okay, what happens if I do that? Well, on this side, if I let x be 0, 0 times anything is 0, gone. 0 times anything is 0, gone. I'm just left with this term. So 0 plus 2 is a 2. 0 minus 1 is a negative 1 times an A is equal to 0 plus 0 minus 1 or minus 1. And I get that negative 1 is equal to negative 2A, or that A is equal to 1/2. And that helped me quickly solve for A. Okay, let's try that again. Let's choose a different value. Let's let x equal to negative 2. How does that help? Okay. Well, if x is negative 2, then this is a 0 and that's gone. This whole part's gone. If x is negative 2, then that's a 0. If x is negative 2, I'm left with c times negative 2. 2 times negative 2 is negative 4. Minus 1 is a negative 5. And then on this side, if x is negative 2, I have negative 2 times negative 2 is 4. 2 times negative 2 is minus 4, minus 1. 4 minus 4 is 0. I get a minus 1 right here. I get negative 1 is 10c, or c is equal to negative 1 over 10. Okay, c is negative 1 over 10. All right. And then, let's see. What if I let x, finally, let's let x be, do I have another color? Did I lose them all already? Here's a purple. Okay, what if I let x be 1/2? If I let x be 1/2, 2 times 1/2 is 1, minus 1 is 0. Then that's 0, and that's 0, and I'm left with this. So I get a b times a 1/2 times a 1/2 plus 2 is 5/2. 5 over 2. That's what I get. On the left side, if x is 1/2, I get a 1/2 squared, which is 1/4, plus 2 times 1/2 is 1 minus 1. All right, so I get 1/4 is equal to b times 5/4. If I multiply both sides by 4/5, I get that b is 1 over 5. All right, that's good. So now I know my partial fraction decomposition for this one is going to be a, which is 1/2, plus b, which was 1/5, plus c, which was negative 1/10. And so sometimes that is a faster method to find your a, b's, and c's. If it's given to that, if your equation is given to that. Okay. All right, that's good. Last one we're going to do is number 4. And it's this crazy guy. So let's look. It's kind of long. Hopefully not too long, though. Let's do this one. All right, number 4. 1 minus x plus 2x squared minus x cubed. Number 4. 1 minus x plus 2x squared minus x cubed all over x times x squared plus 1 squared. All right, it's factored. Good. The power of the denominator is 5, and that's more than that, so it's ready to be set up. So let's see. This is going to be something over x squared plus 1 to the first power, something over x squared plus 1 to the second power. This deserves a constant. This deserves a bx plus c. What's being repeated is quadratic, so this gets a dx plus e. Now we kill our fraction by multiplying both sides times x squared plus 1 times x squared plus 1. And I like to write it out twice. Sometimes that helps me. This is going to both sides. All right, when we do that, On the left side, all of this is canceling with all of that, and we're just left with 1 minus x plus 2x squared minus x cubed. On the right-hand side, it will distribute to each one of these. So what I'm left with, the x will cancel. I'm left with a times x squared plus 1 times x squared plus 1. Okay. When it multiplies here, one of these will cancel, so I'm left with bx plus c times an x times that x squared plus 1. And here, when this multiplies, 2 of these get canceled with 2 of these, and I'm left with an x times dx plus e. All right, so here we go. Let's go ahead and multiply this out. This is going to be x to the 4th plus 2x squared plus 1. This is going to be bx plus c times x cubed plus x. This is going to be dx squared plus ex. All right, let's keep working on this. Distribute the a x to the 4th, 2ax squared, x squared, 2x squared, a. Okay. Multiply this together. Bx times x cubed is bx to the 4th. Bx times x is bx squared. Cx cubed, cx, dx squared, dx. All right, all over here, same thing. All right, now let's equate coefficients. So what I'm going to do is look for x to the 4th. I don't have an x to the 4th term over here. So what that means is add a placeholder, 0x to the 4th. So what x to the 4th terms do I have? I have ax to the 4th plus bx to the 4th. So the coefficients for the x to the 4th over here are a plus b, and the coefficients over here are 0. That's one equation I get. Okay, let's look for the x cubes. X cubes, I have only 1. And I get that c is equal to this x cubed, negative 1. All right, that's good. X squareds, I have here, here, here. So I get that 2a plus b plus d, 2a plus b plus d is equal to 2. All right. Then I have x's. What do I have for x's? I just have c and e. Oh, I thought that was purple. I have c plus e is equal to the coefficient of the x, which is a negative 1. Okay. And then I have a constant term right here. A is the only constant term, is 1. A is 1. Okay. Well, if A is 1 and B is negative A, then B is negative 1. A and B are taken care of. Okay. C is taken care of. All right, let's plug in what we know. A is 1. 2 times 1 is 2. B is negative 1 minus 1 plus D is 2. So that's a 1 plus D is 2. D is 2 minus 1 or 1. There's D. All right. Oh, C is negative 1. Okay, so negative 1 plus E is negative 1. E is going to be 0. Okay, now I'm ready. Ready? A is a 1. B is a negative 1. C is a negative 1. D is a 1. E is 0. And this is my partial fraction decomposition for that one.